Okay, so welcome back. Now, we're trying to figure out, again, a general rule to see what happens to any point that's on here. So what happens to both the x and y coordinates to a point as it goes through these transformations. So looking at our list of transformations here, so remembering that we had a reflection on the x-axis, a vertical stretch by a factor 2, and then left 1 and up 8. Which one of these actually affected the x-coordinate? Again, ignore the y for now. Which ones of these actually affected the x-coordinate? Well, again, going through this last point here that you guys just did, the reflection didn't change the x-coordinate, didn't move it left to right. The vertical stretch didn't move it left to right, only when we moved it left 1. So when we moved it left 1, we saw that our x values went down by 1. So any x value we had was subtracted by 1. And you can see that here with our x values here. When we started with an x value of 0, it wound up at negative 1. We started at 1, wound up at 0, started at 2, wound up at 1. Okay, so that would mean the other transformations all affected the y values. So let's think about what happened here. So let's start with our generic y value here. So when we had a reflection here, we went from a y value of 4 to a y value of negative 4. Well, what happened there meant that our y value changed sign. So that's what the reflection will do. It moves it from one side of the x-axis to the other, so the y value would move from positive to negative. Okay, then we did a vertical stretch by a factor of 2, and we saw that it also multiplied then the y value by 2. So it went from negative 4 to negative 8. So not only was it negative y, it's actually going to be negative 2y. So overall, we had a y value of 4. We multiplied by negative 2, we wound up at negative 8. Okay, and then the left 1 doesn't affect the y value, but the up 8 does. So when you move it up 8, the y value then goes up, well, 8. So we're going to add 8 to it. So in theory, this is a rule that now works for any point that's on this parabola, and if we use this rule, it'll tell us a new point that's going to be on the new one. So let's take a look at it. Let's try it. So let's take another point that's on here that we haven't tried yet. So if we look on here, when x equals 3, y equals 9. Okay, and instead of actually going through the transformations on the graph, let's use our new rule here. So let's take 3, 9 and throw it into this new rule. So if x is equal to 3, okay, the x value is starting with is 3, so we have 3 minus 1. Okay, the y value they're starting with is 9, so we're going to have negative 2 times 9 plus 8. And it's just a matter of figuring out basically simplifying it and seeing what our new point is going to be. So 3 minus 1 is 2. Okay, negative 2 times 9 is negative 18, plus 8 is negative 10. So this tells me that when I start with that, my point 3, 9 gets mapped to a point at 2, negative 10. So is 2, negative 10 somewhere on this new parabola? It is down here. Okay, so it does work. And we could do it again for any other points. We could try this point here, negative 1, 1, negative 2, 4, so on and so forth. And again, it'll all give us points that are on this new parabola. So what we came up with here, this right here is called a mapping rule. Okay, and again, what it is, it's a general rule that will take any point that's on our original graph, original equation, so in this case y equals x squared, and once you throw those points through this mapping rule, it'll tell us where those points are being mapped to on our new quadratic. So it'll give us an opportunity to now be able to graph anything that we want. Okay, so also, just in terms of definition here, these are original points right here, so 0, 0, 1, 1, 2, 4, and 3, 9. The points that we get after all the transformations, after using the mapping rule, these right here are called image points. Okay, so the image points of the original points that we had from y equals x squared. Okay, so now coming up with a mapping rule, hopefully, if we look at the mapping rule and look at the equation it came from, we can start to see a little bit of a pattern as to where the different values came from. So if you see here, if in fact we look at our transformation, we see they're moving left 1, well that told us the x minus 1 part of our mapping rule. We had a reflection in the x-axis, a vertical stretch by a factor of 2, which gave us that a value of negative 2, which told me here that my y value is multiplied by negative 2 in the mapping rule. And this plus 8 in the equation was our shift up 8, which gave us the plus 8 inside the mapping rule. So if we can go straight from getting the equation to the mapping rule, again, we should be able to go through this whole process of making the graph much, much faster.